Good morning and welcome to Module 14 today. And we're going to be talking about allergy towards certain compounds, particularly foods, and sensitivities towards chemicals which are within those foods, as well as environmental chemicals creating a toxic reaction, and chemicals also that we create inside the body, metabolic toxins, which we create as intermediates in our metabolism, which can have inhibiting effects on our body function. So in applied kinesiology approach towards treating allergies and hypersensitivities, we put that because a true allergy is an immunoglobulin response to a protein. That means we've got a protein, a string of amino acids, that's got into the body where we shouldn't normally get that. We should normally chop all amino acids down into single amino acids to absorb, which is the natural way, and then we rebuild those proteins inside the body. But if we get a length of amino acids into the body through a leaky gut or through the skin or whatever it might be, we may actually develop an immunoglobulin reaction, and that's a true allergy. People who react to non-proteins, like glycoproteins, are probably reacting with more of what we call a lectin reaction, and we call that a hypersensitivity. So some people, one of the first people I ever did any work with or got involved with applied kinesiology was a girl who was sensitive to tea ultimately, and this was making her narcolepsy and fall asleep. But as far as we're aware, there's no proteins as such in tea. But there are plenty of chemicals, so she was obviously reacting more from a chemical hypersensitivity rather than a true allergic reaction. So we use it a little bit reservedly. So a true allergy is an immunoglobulin to a protein. A hypersensitivity can be to anything else. So it's an approach towards allergy and hypersensitivity is to identify items in which the patient is allergic or sensitive by how the nervous system reacts, in other words, the muscles, as observed by the control of the muscles evaluated on manual muscle testing. So that's a very good way that David Walther puts down about how in applied kinesiology we approach hypersensitivities. Ideally, by this method of testing, one finds why the autoimmune system is incapable of coping with the noxious substance. So a true allergic reaction is usually an overreaction of the immune system. So we get high levels of histamine, high levels of inflammation. So an allergy is an overaction of the immune system. This is accomplished by the combining reactive substances test with another factor such as therapy, localization, nutrition, etc. So in our approach here, we'd be using a substance. Let's say the person was sensitive to a piece of bread, wheat, or whatever it might be. And then you use another factor, and this, well, the case that I like is to go around the meridian points and see which meridian it is that's associated with it. So if you weaken to a piece of bread and that cross-checks to the gallbladder, you know then that's having an effect on lowering down acetylcholine as a result. And you might then use, say, a vitamin C or N-acetylcysteine or something and find the nutrition that negates it. Okay, so that's the approach that we use. Genetic allergies, sometimes people do have allergies which seem to be within families. And this, I think, especially with true sensitivities to wheat, gluten sort of sensitivities. We know also the story of Pottinger's cats, or most of us do. Pottinger investigated the health of cats back in the 1930s and 40s. I think it was Francis Pottinger. And what he did, he had controls. He took basically cats which had been abandoned, and he had a control and the testing cats. And what he did with the control, he fed them raw meat as their staple type of diet. And I think, if I remember, he gave them unpasteurized milk. The other experimental ones were given basically cooked food, pasteurized milk, and the general rubbishy diet otherwise. And they lost their fur, they aged, they got arthritis, their jaws changed shape, and they got very aggressive behavior. Now, what was fascinating about this, if you see the film, go onto YouTube and you can see the film, just put in Pottinger's cats, is that it took 3 generations to get this breed of cats back out. So then they fed the bad cats the good diet, and then it was the offspring and the offspring and the offspring. Whereas the reverse was with the offspring who were fed the pasteurized milk and the cooked meat. Their children were worse, and their offspring were worse again. So it got to the point where the whole health of the cats, the nations of the cats, got worse and worse and worse. Whereas if you reversed it, it still took 3 generations. So there are factors, and I think this is an interesting point, because let's take in the case of a female, if your mother was deficient in zinc, let's say during her pregnancy, you would therefore be deficient in zinc. Okay, you can understand that. But you as a female, during those 9 months in the womb, your organs were developing. Okay, and one of those organs is, of course, your ovaries, which contain your eggs, and you have a finite number of eggs for life, don't you? Okay, so basically, those eggs would be deficient or programmed into deficiency as well. And that's why you get the 3 generations. Do you see it? So if your mum was deficient, and then you as a girl will be deficient, and then the likelihood is your offspring will be deficient. So if you intervene at any time and build the zinc back in, if that's the thing that you're deficient in, then the next generation may still have a little problem, but they'll be better, and then the next generation after that will be cleared. So what has been shown in research is, in fact, that you can change your germ cells if you supply the things that a person needs, particularly like methylating factors, so that if you take the right B12 and the B6 and the folates and things, it must be that your germ cells actually do change. So epigenetically, we can alter things by intervening with the right nutrients and improve the health of the people. So it's not compulsory because your parents had celiac disease or gluten sensitivity that you will necessarily have this, but the likelihood is if you don't do anything about it with the parents, it'll follow through several generations. So remember, that's the logic of why you get 3 generations of problems. So applied kinase testing is done by stimulating the gustatory, that's the mouth. So technically we put all the foods or compounds that you're going to test in the mouth. Olfactory, which means you smell them. So if you're testing for a chemical and then you inhale the chemical, now this may be not a very good idea, and it may find you get adverse reactions and things, but technically, as far as ICA are concerned, when we test for foods and drinks, we put them in the tongue. When we test for things which are a smell, then we inhale it, and sometimes the cutaneous nerves with the substance testing from strength to weakness. And that gives us a little clue from what David Walther's put in there, sometimes the cutaneous nerves with the substance testing. He mentions about contact dermatitis and putting the compound actually on the skin where the person gets the rash, say. Would make logical sense then. So perhaps we could interpret that a little bit more broadly and say that we may be able to put other things on the skin and have a cutaneous reaction. So the standard tests for allergies, the scratch test. So this is where they scratch with a little pen and then they put the substance on there and see whether you develop a classic sort of histamine type of redness, swelling and rash. The disadvantage with that, of course, is that's not the usual way that you get a bit of egg into you. So if you took some egg, you wouldn't normally get it straight into the blood unless you've got a really leaky gut. So a lot of people do react with scratch tests, but it's not that reliable because a lot of people will react to simply the fact that you put proteins into the blood direct. Then you've got the immunoglobulin RAS tests and the immunoglobulin G, immunoglobulin A. These are lab tests. And then you've got the tests for the immune complexes that arise as a result of this. Kocher's pulse test, which is when you put the substance on the tongue and you feel the pulse rate, and then you measure the change in the pulse rate after a few minutes when something's on the tongue. Very long-winded, but shows a typically sort of adrenaline type of response. When you have something which is detrimental to you, you get an adrenaline response. Philpotts type fasting, basically when you eliminate things from it and then you put them back in and you see how a person is. Again, can take weeks and weeks and weeks. And interesting, Callahan, who came up with the concept of psychological reversal, found that a lot of people develop psychological reversal as a result of eating foods that they were sensitive to. So removing foods that the person's sensitive to can actually have an effect on psychological issues as well. So we'll come back to allergies, and we've covered that, how to do the testing and the response with the 5 inflammatory chemicals in a previous module. So let's have a look now a little bit more into the mind. We technically hear a lot about body, mind and spirit, or it's a very sort of 70s, 80s things here. But we're familiar with the body and mechanics and things, and the mind and the spirit. So we could put these in a slightly different concept, and we could say that the subconscious and the body, or the body becomes the result of the subconscious. So the subconscious is everything that we see, we taste, we touch, we hear, and we feel in every way. So we actually, our perception of the environment around us is the data recording, or called the subconscious. And our bodies become the subconscious, and the more we go through this, we realize that we actually change our gene expression by the thoughts that we put into our head, which is a bit worrying, because if we live with one particular emotion, then our body actually starts to adapt to that, and various brain chemicals and hormones go up or down accordingly. The mind part of this is really related to the conscious and the unconscious. And what we've seen is when we do the test with the finger and with track, the slow tracking to the right there or to the left, the side that goes weak is the underactive brain. So when they stay strong, when we're tracked with a slow pursuit, as it's called in neurology, to the right, and you stay strong, and then you do the same thing to the left and you go weak. That means you're coming more from the right brain than the left, or the left brain's less active. So most of us come from one side or the other, and that's how we see the world or perceive the world that we live in. And so we say that's our conscious side. So you're conscious of the environment around you. Therefore, the other side is unconscious, because we're not aware about what that's doing or thinking or perceiving. So therefore, the mind part is either conscious or unconscious. And the higher part of ourselves, when we want inspiration, when we look up for help, we need inspiration come in, will be the spirit or the superconscious. Freud talked even about the superconscious, the part of us where we get our inspiration from. So health and wellness, we know, is a blend of body, mind and spirit, or the 3 levels of consciousness. So I think certainly these 3, the conscious and unconscious and the subconscious, should all be in harmony. So any of our tests which show that we've got an imbalance, if you like, or something happening in our subconscious and unconscious and our unconscious, when we find the right remedy or approach, everything should be the same, okay, in harmony there. Obviously our higher self or superconscious is always perfect by definition, if you like, so we don't assess that because we have to assume that's what we need to aim for. But the conscious and the unconscious and the subconscious can be 3 different meridian systems that they work through. So you can be a gallbladder on one and an adrenaline on another and a dopamine on another one. So we need to bring those all into harmony. So when trying to understand the mind, it's easier to separate it into 4 different intertwined aspects. But of course the mind isn't a physical thing. It has no location or physicality. It's a concept of trying to understand, how we're thinking and where we come from. So what we know is if we test to the right or to the left with that slow movement, it's not a like that, that's a saccade. So if you go slowly to the right, it's a pursuit. And you do that slowly to the right, muscle test, slowly to the left, a muscle test. And then you find which one goes weak, then you know that's the underactive hemisphere, let's say left and right. Bruce Lipton came up with the concept in his biology of belief that when you look down, you're looking down into your subconscious, in other words, into your memory, your database there. So when people go weak, when they go down, this is an indication that there's a subconscious issue going on. Now this is very accurate, and with the techniques that we've demonstrated, the only difficulty is it's very difficult to stay looking down. Because if you go weak when you look down, you don't want to look down. You know, people then start to come back up. So it's difficult for the patient to hold it in that position. Even if you do a habituation and you do that 3 or 4 times, you've still only got 10 seconds to actually do your testing on. So what we found is the therapy localization to the greater wings of the sphenoid, where the nearest access to the amygdala, or like the rheostat of the subconscious emotions, is a more comfortable and easier way to do it. And to access the superconsciousness, you look up. And this is what we always see and instinctively people do. They look up for inspiration. And it's not that your inspiration or higher self is up there, but it's just the eye movement seems to be able to access somewhere in our brain, let's say, which makes the contact with the higher part of ourselves. So it's a good idea if you need help on an idea, not a physical idea, but something that you want to do in your life, some direction you want to go, to put yourself into that position when you do the muscle test. So you want to ask the higher self for wisdom. If you're looking to look at the memory pattern of a condition or why something is occurring time and time again, and it's a subconscious reaction, then it's a good idea for the patient to look down or to do this across the greater wings of the sphenoid. So we know left and right brain dominance there. The left brain is the more logical, sequential, rational, analytic brain, and the right brain is the more intuitive and creative part of ourselves. And of course we tend to use both. You know, most of us use left and right brain, but we predominantly, in the majority of cases, come more from one side, one hemisphere than the other one. So the dominant hemisphere should be the location of the conscious, and therefore the less dominant, it tends to be the unconscious mind there. So when we look at people, really, we've got to just bear in mind that there's actually 4 minds. Most of the time, what we're looking as physicians is to look at the subconscious, in other words, the database, the memory of everything that a person's put in, which is what you become ultimately. So if you put or perceive bad things in life, you become bad biology. And if you put good things in there, you change the expression of your genes to being good. So let's have a look at a few of the bad things, having talked about that. So the bad things we sort of think about as detrimental to the body systems because they probably inhibit the good actions of metabolism. So probably 90% of detoxification, in other words, the ability to get rid of these toxins, involves the metabolism of endogenously produced chemicals. This was something that Bruce Ames, the world-renowned biochemist, said in far back as 2004 when I first heard that. And this was really quite mind-blowing because he said, don't put so much emphasis on the environment, the pesticides, the herbicides, the plastics and so on. Put the emphasis on the endogenously produced chemicals, because if you're having problems with external chemicals, you've got big problems with inside. So if 90% of your toxicity system is based on internal chemical detoxification, if you become sensitive to outside chemicals, you've got a big problem inside. So you should be looking at the pathways. And the interesting thing is that the same pathways inside metabolize and get rid of the toxins from outside. So therefore, you'll find if a person has, let's say, an acetylation problem, they've got an acetylation problem to internal chemicals as well as external chemicals. It'll be the same pathway. And that's what we've got to try and identify, is what is the pathway in each one of our patients and ourselves that is not functioning, or pathways sometimes that are not functioning properly. And if we can upregulate those pathways with the right nutrients, then we can then begin to detoxify better. So remember at this stage that 90% of detoxification involves endogenously produced problems. So therefore, what are these substances that we produce inside? So we should be looking at those and thinking, yeah, I produce a lot of phenols, or I produce a lot of other compounds, aldehydes, etc. And why is it I'm making these, and how do we detoxify them? So let's look at the principles of functional biochemistry to make sure we're all singing from the same hymn sheet, as they say. We know that we have enzymes, which are proteins, which catalyze the conversion of substrates or beginning substances into our end products. And there's 7,000 plus of these in enzyme databases. We know that enzymes are proteins, and proteins have a gene. And we can measure these genes. We can look them up in databases and things. But basically, the enzymes are the manifestation of the genes, and the genes are the programs on each of the chromosomes. There's usually two types of enzymes: those that need coenzymes, which, if you remember, mostly the activated vitamin Bs, and those that do not require coenzymes, such as the digestive enzyme. So there's four parts to the enzyme: the apoenzyme, which is really the working part of the enzyme itself. Then we've got the coenzyme that actually joins in with the enzyme there and donates something to the equation. It could be a hydrogen, it could be a phosphate group, etc. Then we have cofactors. So cofactors and coenzymes are different. Cofactors are metals, elements, minerals, such as iron, copper, zinc, manganese, selenium, copper, cobalt, etc. And we can have metal-activated enzymes, which are usually the alkaline earth metals of sodium, potassium, magnesium, and calcium. So these would be your minerals that help to activate the enzymes to get them to work. So we know that enzymes are made of proteins, which are strings of amino acids, and that some amino acids have a positive charge and some have a negative charge. So if a mineral cofactor attaches to a positive or a negative, it actually changes the conformation of the enzyme. So in other words, the shape. So if we've got a positive here, say we've got a negative charge here, and we put a positive onto it, the enzyme straightens out. Okay, so we actually change the structure of the protein enzyme physically. It literally changes its shape. And this is how digestive enzymes are a good example work. They work physically. They actually change their conformation and they crush the food. In this case, it might be the carbohydrate or the protein. They actually literally crush it. So these little enzymes, these strings of proteins, are physical movement all the time. They're not just strings of linear protein which sit around and change chemicals. They're actually moving and physically active. So we know that probably 80%, Jeff Bland always quotes about 80% of enzymes use magnesium as cofactors. So you can see magnesium comes up a lot of times, and probably followed by zinc. And that may depend upon geographically where you are in the world as to whether you need to supplement these in. But we find that most people, more often, as far as minerals are concerned, it's going to be magnesium, zinc, magnesium. And this is probably due to intensive farming, where you're depleting a lot of the minerals out of the soil. And so people are having to use supplements to help their biological functions. Manganese comes up quite a lot, selenium comes up quite a lot. We don't have so much problem with calcium. Occasionally we have to supplement calcium, but here in southern England, where we've got a lot of chalk, we've got a lot of calcium in the water and things and the foods. So here we see a classic enzyme called carbonic anhydrase. This is an enzyme basically that regulates the pH in the body. It comes up in a lot of systems, not just in the stomach, but it's in the cerebrospinal fluid, it's in the kidneys, etc. And it regulates whether the tendency of the tissue is too acid or too alkaline. So carbonic anhydrase, and it's a zinc-dependent enzyme, which is here in the middle. Basically, we have carbon dioxide and water coming together to make carbonic acid, and then that donates the hydrogen here and the bicarb. So basically, carbonic anhydrase produces hydrogen ions, which go on to make acids, and bicarb, which go on to make alkaline. So very clever, it makes both sides. So in the stomach, we add the hydrogen to chloride, which makes hydrochloric acid, which makes the stomach acid. But the bicarb is shunted off to the pancreas and the pancreatic juices, so that alkalizes. So the pancreatic enzymes work better in alkaline, whereas pepsin in the stomach works better in an acid environment. Then we have low molecular allosteric effectors which can lock into the protein enzyme and again change its conformation. They're not essential, but they act like boosts. And I always think here silver is a very good example with myeloperoxidase enzyme. It acts as a boost to stimulate the production or activation of myeloperoxidase to make more hypochlorite to help us kill off, all the gram-positive bacteria. Factors that affect enzymes is the temperature. So when we want to activate certain enzymes, we increase our body temperature, particularly the immune system, myeloperoxidase, etc. The concentration of the enzyme, the substrate, there was the amount of the beginning substance, the pH, some enzymes work better in an acid and some in an alkaline, as I just said, and of course the inhibitors that can poison enzymes. And here we begin to see our types of poisons that may come in, and these would be things like toxic metals, mycotoxins, which we saw yesterday, and a whole range of chemicals. And a lot of these chemicals are things we sort of take in our food, slap on our face, put on our hair, clean our body with, and we call those toiletries and cosmetics. So a surprising number of people are actually sensitive to these, not directly necessarily on a dermatitis on the skin, but they take these chemicals in and a lot of them are gender benders. They alter the function of hormone or the enzymes that make certain hormones. And so you can actually change your hormonal expression if you put enough of these things onto your body. So we know substrate is the beginning, end product is the end product. So a person who has a deficiency of the end product will always strengthen to the end product, and they will weaken to the substrate if there's a problem with that enzyme. And to help that, to open it up, we can supply the mineral cofactors and the coenzyme, where applicable, to donate a hydrogen or a phosphate, whatever it might be there. So we'll cover that through.